We're going to talk about solving equations and inequalities with absolute values. Don't worry too much about what the absolute value is. We can talk about that more tomorrow when I get back to class. But for right now, here's what it looks like. The absolute value of x is the distance a number is from 0. And since distances are always positive, the absolute value of 3 would be 3, and the absolute value of negative 3 would also be 3. So the absolute value for right now, think of it as a number that must be positive since the distance is positive. And you can see below, right over here, is the graph of y equals the absolute value of x. And notice that when x is negative, y is still positive. Right? Negative 4 is 4 units from 0, and when it's positive, it's also positive. So that's the kind of graph that we'll be looking at or playing with a bit in Desmos to solve. For right now, I'm just going to show you how to solve these in Desmos. So let's just look at a few problems. And I put the graphs here already, but I'm going to take you to Desmos to do one so you can see how to input it, and then I'll tell you what to do to solve for it. So let's do the first one, solve absolute value of x plus 2 equals 5. So in Desmos, what I would do is I would create one line, and I would type in y equals, and then right here in the lower left, right above the ABC button, is absolute value. And then I would put in x plus 2. And don't worry about how the graph is shifting. And then that's the left side of the equation. And then I would type in the right side, y equals 5. You can think about how it's shifting right now. But for right now, don't worry about that part. And so then there's the graph that you would analyze. And so I'm going to go back to the other screen so I can write on it. And so how do I know where the two things are equal? Well, they're equal where their graphs would intersect. So the answer to this one appears just at the intersections. So right there and right there. And remember, we are looking to solve for x, so I want the x values. So in this case, one of the answers would be negative 7, and the other answer would be positive 3. Now, since x cannot be both of them at the same time, when it's equals, equals are always or problems. And we can think of that, of how that works, right? Negative 7 plus 2 is negative 5, but the absolute value would make it a positive 5, or 3 plus 2 is positive 5, and the absolute value keeps it as a positive 5. Now, graphing on a number line is fine here. And since they can only be equal, then we just put the closed dots. There are no arrows necessary because there's no greater than or less than happening. In interval notation, we don't bother with. There's really no interval that's going on here. It just wouldn't be interesting or helpful. Okay, so that's how you would solve it on Desmos. Just the first part here, you would put on one line, and it would be always y equals to that expression. And the second part you would put on the second line, y equals 5, and that's how you get the graph, and then you'd analyze it the way I'm showing you. So so let's go on to a couple of the inequalities, and then you can try some of the problems. Again, I'm only expecting you to solve these using Desmos for right now. So okay, so let's do a less than. Here's x minus, absolute value of x minus 3 is less than or equal to 1. So notice, here's your graph of y equals the absolute value of x minus 3. And here's the graph of y equals 1. And we want the part that's less than. So less than would be below the line. So it would be that part right there. Just that little bottom part of the graph. And so again, we want to know when we're looking for the value of x. So where does that little yellow part happen? Well, it happens between 2 and 4. And notice it kind of looks like a curved and problem, how and problems are usually between the two numbers, and that's exactly what it is. Less thans would be and problems. And so here I end up with x can be greater than or equal to 2, and x can be less than or equal to 4. Right, and one way you can look at that, even you can use the y equals 1 as a number line, right? And there's your answer right there. It's all the places on the x-axis where the absolute value graph is below the number. Now this we can obviously graph and do interval notation with. So here's the graph. All right, we're used to that. And one thing on the quiz while I'm doing this, a lot of you when you did this would write the answers, but you would leave off the and and the or. The and and the or are part of the answers when you're solving. And so there's the interval notation. And this on Desmos, you would type in y equals the absolute value of x minus 3 on one line, and on the other line would be y equals 1. All right, let's try a different type. Again, you can think about how the absolute value graph is moving around, but don't worry about it if it doesn't make sense right now. So let's solve a greater than problem here. And so we're going to solve the absolute value of x minus 4 is greater than negative 1. All right, so on Desmos, we're going to type in y equals the absolute value of x. And on this, absolute value of x minus 4. And on the second line, we're going to type in y equals negative 1. All right, so here are my boundary points. That's where they meet up. But actually, sorry, they're not allowed to be equal, so it's an open circle. And then where is this graph greater than negative 1? Well, anywhere above negative 1. So on the actual absolute value graph, it would be anything above negative 1. And so in this case, on the number line in a sense, it would look like two arrows going in opposite directions, and we know that to be an OR problem. So what is the answer to this? The answer to this would be x is less than negative 3, or x is greater than positive 3, right? And we can just almost in a sense copy the number line over. Don't forget the open and closed circles still apply. And then the place this works is off to the left and the right. And so interval notation for this would be negative infinity to negative 3 with the union symbol, 3 to positive infinity. All right, let's do one more. We're going to solve this again. Don't get caught up in the actual, like, why the graph is where it is. Let's just learn how to solve with it for right now. So on Desmos, one line is y is the absolute value of 2x plus 5. And on another line, y equals 3. And so you can see that on the graph here. There's your y equals absolute value of 2x plus 5. Here's y equals 3. Right, and so again, it's an open circle. And then the place on the graph where it's greater than 3, just like the last one, is everywhere above 3. So this here again is an or problem, right? And so on the number line, if we want to think of that as the number line, it would look like this. And so the answer here would be x is less than -4, or x is greater than -1. Remember, we are not plotting the y values that we're getting. We're plotting the x values of those intersecting points. So the graph would look just like you see already on the screen. And the interval notation okay, so try the problems. Just make sure you're using Desmos correctly and typing things in correctly. But otherwise, every problem, at least Desmos-wise, is the same, and we can talk more about what is actually going on tomorrow. So just very mechanical today. Good luck, and hope to see y'all on Tuesday.